Hello everyone. So today we are going to solve 22nd of August gigs for gigs problem of the day. That is number of terms in the binary tree. Uh, I would suggest from this problem you would understood many multiple concepts of the binary tree like how to find LCA, that is a famous problem, that is lowest common ancestor, and how to traverse the tree from root to leaf nodes. If you don't know these things, you will get like from this problem, you will get all those things in a better way. So I will try my best to explain. Let's start the problem. What it is saying is you have given a root of binary tree and the values of its two nodes that are P and Q, and you have to find the turns. You have to find the total turns required to travel from node P to Q. Okay, so we have given this binary tree and we have given 5 and Q as the P and Q values. So you have to find the path from P to Q, and you have to find the like number of turns that are coming into that path. So there can be a possibility like P and Q can be multiple, but as they have mentioned, all the node values are distinct. So it means P and Q are distinct. They are only present once in the tree. And we have given when the turn considers. So whenever the direction of the movement changes from left to right or right to left, then we are considering a turn. And if the path between the two nodes does not have any turns, so it is going into a straight direction like 4 to 1, and consider we have P is 4 or Q as 1 and or vice versa. So we are going 4 to 1. There is no turn we are going in the single direction. So in that case, we have to return the -1. Otherwise, we have to count the turns. So consider this example only, this binary tree and P5 Q10. Let's go to whiteboard and see how it will look like. So if you don't know how to create a tree also, so I will show you. Like you can start from the root node. You will see the next nodes 2 and 3 that will be left and right node. So this one, and then 4 and 5. So it will show you like this. If you know how to, you can skip this part. And 4 5, then it is 6 7. So this is 6, this is 7, and this is 8. And null is saying like there is no node for this right node. Then two more, then they are not nodes. So here, then this 9 will come and 10 will come. So this binary tree we have given, and we have given P as 5 and Q as. So this is node 1 that we have to consider. And this is the second node that we have to consider. And we have to find the path from here to here. First thing is, don't forget the problem. Let's do this simple mathematics, simple algo, like what it is saying. So you have given P node, you have given Q node. What is the path from P to Q? Forget about the number of turns and everything. What is the path? So path is 5 to 2, you can go, right? If you're going to 2 to 4, there is a path. No, from 4 to 10 you cannot go, right? You have to come back to 2. There is no point to go to 4 and come back to 2. So the path will be 5. Okay, you are starting from 5, you are going to 2, you are going to 1, you are going to 3. Okay, 5 to 1 3, then you are going to 6, then you are going to 10. So this is the path that you have to do: 5 to 1 3 6 10. Now you have to find the number of turns that are coming into this path. That is the problem. So first thing is you have to find the path. You have to understood what is the path that we are going to cover it up to understand the problem. Second thing is to find the number of turns. What are the number of turns? Consider we are starting from 5. I'm going to 2. Okay. So I'm going in the right direction first. And at the 2 side, I'm going to left side. So consider if I'm standing at 2, what I'm saying is some value P is coming from to me from the right side, but I am providing the value to my root node or to my parent node from the left side. So it means there is a turn at 2, right? Because try to consider to stand at the node 2 and see like from where the value is coming and where I'm sending that value. So it is sending coming from right and sending to left. So it means there is one turn at 2. So it means 2 at 2 is one turn is there. From 1 same, one value is coming from left, but I'm going into the right direction. It means there is a turn at 1 also. So there is a turn at 1. Standing at 3, I am coming from right, I am going to left. So it means there is a turn at 3 also. At standing at 6, I am coming from left, but I'm going to right. So it means there is a turn at 6 also. So it means there are total 4 turns in this problem, and we have to return this count, that is 4. So answer will be 4 for this. Okay, now consider the same example how we will solve this problem. Okay, so let's take. this example once more time. So how we will solve this? Consider I am standing at root node. I don't know anything about this. Okay, I am standing at the root node and I need to find out the what is the path from root to P. If somehow, let's consider, if somehow I found the path that I'm trying to do is okay, right? Because understanding is like because we have to find the P to Q. So consider I am at the root level and I will find the path to P node and I'm standing at the root level and I will find the path to node. So if I will find these paths, I will be easily find out what are the number of turns required in that, right? So consider find the root. Root is 1 and P is 5. So what is the path is this? This is 1 to 5. Okay, this is 1, 2, and 5. And root to Q. Root to Q is 1, 3, 6, 10. Okay, I will write this also 1, 3, 6, and 10. Now see this one. First, root to P, that is 1 to 5. 1 to 5. What I'm doing is here, I am going to left and I am going to right. Let's write this also. 1 to 5 is left to right. I'm writing here left to right. 1, 3, 6, 10. What I'm doing is right, left, and right. I'm doing right, left, and right. Okay, I'm trying to explain very beginner level. Like if you don't understood this problem, please try to rewatch this video. But this will be the like I'm trying to explain every aspect of this problem, like how you create a binary tree, how you think about this approach, how you think about the problem. Okay, so see, if I write this 1 to 5, the path come to me is left, and then I'm going to right. This is a path, right? If I'm going 1 to 10, what is the right, left, right? This is the path. Now I need to find out the P to Q. What is the path? So path is the same, right? If I'm going like in the reverse direction, right, left, and then right, left, right. So it means the path is the nothing but it's reverse of this. If I'm doing the reverse of this plus this path. So this will be my answer, right? This will be path that we have discussed. This will be right, left, right, left, right, right, left, and right, left, right. So this is the path. So it means the path will be, I'm writing here. So path will be finally right, left, and the other path is right, left, and right, reverse path. Okay. What will be the like final like what we are going to do here is so it means we have to we have find out the path from the root level to the one particular P node, we have to find the path from the root level to the Q node. I'm taking consideration of this particular example. I will show you one more example. If the root is itself a P node or Q node, okay, then we will see it again. But consider this example, you will understand many multiple things. So you will find out the path, and the final path will be my reverse of this path plus this path, right? So it means this path. So here, what will be my total path? Total path will be right to left, merge this path. After this, right, left, and then again right will come, then again left will come, then again right will come. Now you will understood what are the number of turns, because if you are standing at here, left turn, I'm coming from right, but I am at the left turn, so it means there is a turn at here. If right, it means right and left are not matching, it means there is a turn. Left and right are not matching, it means there is a turn. Right and left are not matching, it means there is a turn. So it means there are total 4 turns are there in this. So you will find out, okay, easily. So for this, what we need, how to find this left and right, right, left, right, then I will explain you. But you need to understand where, how we can came up to this approach, how we come to this here. Like we need to find the traverse path from the root to that particular node and root to that particular node. Okay, let's consider one more example. So consider we have something root node, and consider we have something 1. This is, value is considered 1. This is 10. This is considered 2. And we need to see like consider we have 20. Okay. And we have given P as 1 and Q as 20. So it means what it is saying is this is the one node. This is the another node that you have to find the path. Again, we will go to that path. So root to find the P level path. Root to P level path, but it is left and left, right? So this is my root level. I'm going to, this is my root level. I'm going to root to left. What about Q? So for Q1, this is the Q is, sorry, Q is 20. So this will be my second path, and root to P is the only this one. So there is no like I don't need to go anywhere because root is itself is the my P or Q node. Okay. In that case, it is a P node. So I don't need to go anywhere. Then it means then I don't need to merge anything to this my path. So what will be the my total final turns? So if I'm standing at here, if I'm taking any turn, no, because left is left. So there is no turn I have to, and I crossed out, and this will become turn is equals to 0. So there is no turn that I have took. So in that case, we have it is a straight path. And according to problem statement, we have written the -1 in that case. Okay, let's consider the third case. In that, we have given, so sorry, consider sorry for this disturbance. Like, okay, consider we have given the third example that is, mm, we have given something like the same example. I can took this example. I don't know what is happening, but okay. So taking the same example, consider we have something, this is the root level, and we have considered something like this is a binary tree, and there is a some node, and there is a some another followers of the node, and there is air. And we have to consider like this is something P, this is Q, anything you can consider like in this tree. But I want to suggest here is this is the LCA of the node, okay, and this is the root node. Here in this example, our root and LCA is the same. What do you mean by LCA? LCA is lowest common ancestor. So it means for this P and Q node, what is the common node in the hierarchy level? There the segregation will stop. Like basically their parent, their parent, whatever the final value is same, that we would say it is the lowest common ancestor. So it means for this node, if I'm going to this, if I'm going to this is a node, and both the junction are matching the at this node, so we could say this is the lowest common ancestor. But in this case, lowest common ancestor of the 5 and 10 are matching with the 1. But in this case, they are not matching with the root level. Consider root is the above itself of like parent of parent or whatever the grandparent of this particular node. So in that case, we will find the again like the approach will be same. We will find the root to this particular node level. We will find the this particular iteration of the path, left, right, whatever it is. Same for the Q node, we will find out. And we will remove these nodes, like whatever the coming to the root to LCA node, we will remove these common nodes so that we don't need to bother about this, and we will just take the consideration of the important path. Okay, we don't need, right? Because these are the common nodes, and from root to LCA, these are the common path that we are traversing in the both of the use cases. There is no point to go into that. So we will remove this, and we will just taking consideration of this path. That is the varying path that will give us the number of the turns. Okay, so I hope you will understand the problem. Now coming to the point is how we will find the root to a particular node, the path that we have considered like left, right, how we will find that. So uh, let's take one example, how we will see that one. So consider we have some example that 1, 2, 3, 4, and 5. Consider we have to find the 1 to 5. Okay, I consider one data structure, consider that is the one data structure I have considered, and I'm starting from 1, and I need to find till the path to 5. Okay, so what I will do first, I will check is the path, I don't know where it is present. I don't know if it is present in the right or if it is present in the left, whatever, where it is present. I will start from 1, and I will see, okay, is to I came here, I will append, like consider I am going in the left direction, so I will append L, or you can consider complete left or right, but I'm taking one character left. I came at 2. Is 2 is equals to 5? No, it is not equal to. I will go again to left. I will check. Okay, I will append left. Is 4 is equals to 5? No, it is not equal to 5. So it means I need to backtrack, right? Because there is no need to go further because there are the null nodes. So I need to backtrack to 2. So it means I need to remove this left node. I will go to this 5. Is 5 equals to 5? Yes, it is 5. So it means I'm going in the right direction, and I found out that particular node. So it means the path is the left or right. If the path is right, consider 3 we need to find out. So it means 5 is not equal to 3. So it means we need to backtrack. We will remove 3. We came at 2. Okay. Is 2 equals to 3? No, it is not. So we need to backtrack. We backtrack. We came here 3. Append R, we came at 3. So 3 equals to 3? Yes. So it means path is the right R only. So like this, you have to find it. So you have to divide this problem into multiple chunks. One thing is you have to find the root level. This is the important point of the video, like most important, that in which part, in which particular manner you have to approach this particular. So first thing is you have to find the from the root level, whatever the P or Q node, whatever wherever their nodes is, you have to find those paths particularly. And path, for finding the path, you can use this data structure. I'm using this as a list because we don't need to do anything else. We have to just remove the last value and appending at the last. So I can use the list. And now the if you find the path from the root to P and root to Q, now you find both of the paths. Now you have to remove the common one. Common one means that we have took one example, right? Root to LCA node. So that you have to remove the common ones. Now, if you removed those common ones, now you have to reverse the P to path P that you have taken, path P, that you have to reverse that path and merge with the like right Q node path, and then you need to find out the number of turns. Nothing else. This is the simplistic approach that you can go with. And let's see the code I've written in the Java. But if you are comfortable with Java, you can follow this. Otherwise, you can write it in your preferred language. So what I'm trying to do, I try to write the algorithm in a very simplistic manner. Like what is the path to P and path to Q? That array list that I've taken, and I'm finding those paths. Find path root to P to path to P and root Q to path to Q. I will show how this code is work. So consider I find out these paths, and there is no particular path or any like as cases, then I'm considering it as a return minus one. There could not be a possible solution. But if there is a possible solution, then I'm going here. So I'm finding the root to LCA prefix. Okay, LCA prefix is, consider the same example. You are coming starting from the root, you go to something L, you do L, and you do L. So consider root. So you again do something L and R and consider L. So this is the common prefix that you don't require, right? This is the common prefix you don't require. So you need to start from here only to find the number of turns. So you can remove this path. So for that, I'm taking as a common, and common is a path to P size, common is path to Q size, and I'm checking if those are equals. So I'm just incrementing the common, and I will come here L and R. Then I will reverse this path, right? I need to reverse this path. Now this path is root to P, LCA to P. I would say LCA to P, but I need to find the P to LCA, right? Because our answer will be P to LCA to Q. This will be my answer, right? P to LCA plus Q. So we have the already path from LCA to P. If we will reverse this, then it means we have path from P to LCA and LCA to Q. We will merge. So what I'm doing here is, so travel back from path P to Q. So that I'm finding the path in the reverse direction from path P, and in the like LCA towards Q, I'm going in the same direction from common. And now I have this path array list that I've contained from P to LCA to Q path. And now I'm going to path to size, and I will check if that particular node is equals to the previous node, like direction, I would say, then it means there is no turns. But if they are not equals, so it means there is a turn. And finally, I will check if the turns are equals to 0. It means that this is a straight path. Then we have to return -1. Otherwise, we have to return the number of turns we have encountered. Coming to this find path, how you will find out? We have root, we have one target node, and we have path array that is initially empty. So we will check root equals to null. There is, it means that we don't need to do anything. We will just return false. If root dot data is equal to target, it means the root target means like consider P is 1. So this is the case we are taking care of. So if this is the itself is a root node, is a like target node, then we don't need to anything. We just return true. It means there is a path exist, but that we don't need to append anything. Otherwise, just I mentioned like we will append the L, and I will try to find out the particular path. If that will give me answer, then I will return true. Otherwise, if it is not giving me the answer, then I'm removing that particular variable that I've appended, and I will try to find in the right direction. If I found the path, it's better. If it is not, then I'm returning finally as a false. So now you can think about this, like what are the important steps? So important steps that you have to find out. Again, I'm repeating it. You just need to do you it's a very simplistic algorithm, but shown in a very different way. You just have to find out what are the values. Okay, try to find out the path. I would suggest try to find out the path from 5 to 10, 5 to 6, multiple paths you will write. You will understand what is the problem is saying is, and you will find out like, okay, what we need to do other than else is like you just have to find the P to LCA node and LCA to Q node. If you find out this path, it's nothing but just a array list problem, and you have to iteration over that, and you have to find the number of turns. Okay. And if you so guys, if you learn something new from this video, you if you go to this approach, I would highly request you. So please like and subscribe my channel. It will really motivating me to continue. And if you have some doubts, you can comment over the video. So thank you everyone.